So my name is Fhon Supmak. I'm a CEO of Oxford Vision and Sensor Technology. So basically, the company provide the software and services, including the hardware, to automotive manufacturing. So our product are the innovative 2D and 3D vision technology that mostly integrated with industrial robot that do the robot guidance and inspection for the manufacturing in production line. So today, we're going to cover the topic of machine learning, including 2D and 3D vision system, robotics, and AI, particularly related to the practical experience that our company have worked with the industry. So we can see from here, the technology of machine learning and vision system, robotic and AI, they are integrated very tightly, working together in the manufacturing process. So in here, you will see a multiple applications, including robotics and machine learning or vision system application and different type of industrial 2D and 3D sensor, including some application that in this one is the robot 3D vision and robot guidance system at Ferrari in Italy, which we can see further to see what the system is doing. And about the company, so Oxford Vision and Sensor Technology, or OVST, and as mentioned earlier, that we design and supply 3D vision sensor software and services to automotive manufacturers. Our customer, as you can see, like in the UK, Aston Martin, Jaguar Land Rover, and we also do the overseas customer as well, such as like Honda in Canada and Ford in Spain, and in Cologne and multiple countries in Europe as well. So for OVST, we provide the industrial automation solution mainly for the machine learning application, including robotics. And we also develop our online learning platform, which the integrated the virtual hardware and software allow the user be able to learn the industrial experience without the need to use the hardware. As we can see that there is limitation of access the hardware such as robotics and 3D vision system because of the price tag on them and availability of data on the industry. So we hope that the OVST EdTech will allow the user, including professional and student, be able to learn the industrial experience without the need of hardware. So I think it will be beneficial for us to see our experience because I know that a lot of you might have great experience on, like academic and research, and a lot of you have been entering courses that understand very well industrial automation, but it might be worthwhile to understand how this industrial application actually being used in the industry. So as we can see here for our product or our application, like when talking about machine learning or vision system, we can see that the application, we can run the robot guidance system and laser stream tracking and 2D, 3D inspection system, or even defect inspection built on the deep learning or identification system to read, like the VIN number or verification identity number from the automobile, basically. So various applications that machine learning can be integrated with robotics. And in addition that this integration, they often have the data storage, and now in this day, the manufacturing want to see the data globally so that we can integrate this storage data into the cloud for that everybody be able to access such data anywhere as well. And we have been collaborative with Coventry University for quite a long time, and I'd like to show a short video to see our product and how we actually work with Coventry University in here. So we can see here is example application for 3D vision and robot guidance application running at Ferrari in Italy. So we can see that vision system can do inspection and measure, and then insert the glass to the roof of the car or to the windshield precisely. So this automation help manufacturer to work more efficiently and help on product quality as well. And we create our own software and hardware technology. As we can see, our 3D sensor that have different 3D technology for SRS and stereo vision, including the 3D point cloud, all of which have been served in multiple applications. And we can see example here in our workshop that the vision system integrated with robot. It can do the measure for the aperture of the tailgate. And with this computation in the software, it can compute the measurement and be able to send that offset or the measurement to the robot. Then the robot can pick up the glass and insert the glass to the car body accurately. So this gives you example of how the system work in the workshop. So as mentioned that we have OVST EdTech that allow, as you can see, all of the platform for hardware and software in manufacturer. We can do that in emulator mode. As we can see here, the simulator of Ferrari is just running in the PC. So on top of that, if we know that the IoT is widely used everywhere in the industry, our system can integrate the data on the cloud, and then the user can able to see the log data and everywhere on their fingertip using the mobile tablet and devices. And talking to industrial experience, we can see multiple applications. As you can see here, guidance, inspection, tracking system, and measurement and deep learning application, all of which is growing from the machine learning principle integrated with robotic application. And we have been working to share our knowledge to the students so that they can gain experience from academic, the great academic from Coventry University, as well as the industrial experience from the industry like our company. And I'd like to go a bit in detail about our product so that you can see how actually the application work on the industry. So first start, I'd like to share with you the Glazer 3D robot guidance system. So basically, the system we measure the car and then understand the position of the car aperture in order for the robot to pick up the glass and insert the glass to the car accurately. So we're understanding what's the problem we have for this system. So in the past, and even in this day, some manufacturers still use the manual operation. For example, in this slide, you can see we need two operators to pick up the glass and insert the glass to the windshield manually, which we can see the problem that, first of all, is the accuracy and the quality and efficiency as well. That's why we have the automaton system that allow the manufacturer to run more efficiently. So as you can see here at the production line at Jaguar Land Rover, we have multiple robots do the measurement of the car using our sensor technology. They measure the aperture of the windshield and the tailgate, and after computation, they send the offset in 6-axis X, Y, Z, and rotation to the robot in order to press or insert the glass to the car precisely without the manual operation, with a better quality and accuracy as well. So this is how the automation can help the industry to be better quality and also more efficiency as well. And we can see very similar system. This is our application installed in Italy at Ferrari plant. Very similar in automation production line. We try to minimize the manual operation, and this as well use the robot to insert the windshield to the car without the manual operation. And apart from the guidance system, many manufacturers need to improve their quality system. Hence, they use the machine learning or vision system for the inspection application. As we can see here, that the various 2D vision system inspection, 3D vision system inspection, and all of which have held the production or manufacturer for the better quality control. As we can see here, example as Aston Martin for the application used to inspect some component using both 2D and 3D sensor, which we can see the real application that actually running at Aston Martin in Gaydon in the UK. So we can see how this system work in the real manufacturing process. As well, not only Aston Martin, our system installed a Jaguar Land Rover. So we can see that they use the vision system to inspect the chassis, which have multiple inspection points, which will take time and less quality control if we use the manual inspection by the operator. And we can see here for various of application, either robot guidance application, inspection system at Aston Martin, or the chassis inspection at Jaguar Land Rover. All of these have been used widely in automotive industry. So at Aston Martin, we used 30 cameras for each these windows to inspect all of the nut and bolt and part to check present absent and quality control to ensure that every single car have been assembled with all the components needed with all the right placement for individual of bolt and nut here. So we can see as well that the real application at the manufacturing. So we can see here as well for the inspection in production line here at Aston Martin. So the pattern of the car parts that come to under vision system, they do inspection and provided the inspection result that the operator can see pass and fail and do the intervention as needed. And at Aston Martin, we know that they do the process of bonding. They put the glue on the car part to be able to embed them all together. Hence the reason that they need to check the glue quality and position. We can see here for 2D vision and 3D vision sensor, they all have different application, but they can work at the same application for the purpose of inspection, which you can see in demo system here. The 3D can scan and get the scan 3D images alongside the 2D images in the same application. And then they will process and compute the measurement and getting the data into the cloud so that the user can access the data anywhere and anytime. And with the IoT, allow the manufacturer industry to be able to make use of data more widely so that we can see here from the simulator with the robot without any hardware, and we can see that exactly the robot that's running in the manufacturing and the actual application that's running in the production line, all of these can just run virtually in the PC that allow the user to program to debug just in the computer and be able to save time to make improvement accordingly. So this is the benefit of using the simulator and OVST EdTech learning system for the professional and academic to be able to learn industrial application. And we can see here as well that I've mentioned the inspection system at Jaguar that we do measurement for multiple points of the chassis inspection, which I can share with you here for the application that how it works, that the chassis coming to the production line here at Jaguar and the inspection system inspect automatically, and then indicate pass and fail for each individual inspection, allow the operator to work with the better quality and control in their production line. So here is the actual example at Jaguar, and we can simulate that using the MacVision Mobile, which allow anybody to simulate the industrial application using just a mobile phone, which is quite helpful so that we can reduce the cost of hardware that oftentimes we are not afford to purchase the industrial equipment. So we can see that we can use just the mobile phone and simulator system that allow us to run fully as we actually run in production line at the manufacturing shop floor, which allow the learning and testing more efficiently. So here is example of demonstration of MacVision that you can see. We have the robot that taking the image using the mobile phone, and then the mobile phone transfer the image to the application and do the computation and measurement accordingly. So as you can see here, we change the industrial hardware into just a mobile phone, allow affordability for anybody to do the industrial application. And all of which can be upload the data into the cloud and allow the user to access the data anywhere. So all of these allow the user to be able to use the simulator, program it, and able to see the data as in the manufacturing that run in the industrial application. So we can see here the comparison of production line that we have here, we already done, sorry. So we can see that in here, sorry, I messed a little bit here. So we can see that apart from the 2D, 3D vision system application that we see nowadays, the industry have shifted toward robotic integrated with AI and deep learning. You can see the journey from 1950, the artificial intelligence and machine learning have changed over time. So now is a time that every manufacturer looking for advanced technology to use the deep learning and AI to make their process more efficiently. So we can see that the application of robotics integrated with AI and deep learning have been using in healthcare, manufacturing, agriculture, transportation, smart home application, and aerospace. So it has been used nearly all the industry we see now today. So in manufacturing, the manufacturer using multiple robots integrating with the AI technology to work with the inspection, guidance, tracking to make the system work smarter. And even in the warehouse, like a company like Ocado, they use multiple of robot and AI system to work alongside to avoid less manpower or using manual operation. So we can see that even the warehouse and application like in grocery, they also use technology such as the robot and application of machine learning and AI to improve their productivity. In the same way, in inspection application, with conventional change from conventional inspection application, now today you will see a lot of manufacturing using AI and deep learning to do the inspection system. And we can see as well that it not only will replace the people with the robots, but we allow the technology like robotics and vision system to work with the people as well alongside, which we use with the collaborative robot that allow the operator and the robot to work together very beautifully. So I would like to share a little bit of application of our experience that we work with a company in the US, application for machine learning and deep learning, and how that machine learning and deep learning can improve the productivity and efficiency of the application. So you can see that conventional or traditional classifier or machine learning, we have the input layer, we have do the computation and learning the model, and then you can get output that we can learn the training model. Comparing to deep learning, we can have multiple of deep neural network, allow the system to be more complicated, but as well work more efficiently to have many more of learn trained database to be able to detect the object or inspection more efficiently. As we can see here, the traditional classifier, we feed in the same input and we do classification, and that can identify the real defect or the false defect, so that we have the user have to train something like the feature extraction, train the model, and then classify individual model. Then we can get the output to identify the true or false defect. But with deep learning, we can optimize parameter by training multiple data that allow multiple neural network, so that the system can be more automatically reduce the defect in the manufacturing. So we can see that with multiple neural network, it works more efficiently. Hence the reason that a lot of manufacturers turn into the deep learning and machine learning in AI application. So we can see the advantage of deep learning, that we can make use of the neural variation in the data, so that we can do the self-learning, so that the user can just add on the multiple data and then name as this data it passed, or annotate this data it failed, so that the user can just feed in the data. The more data that it trained, the better the system will be. So it minimal the human intervention for the user to train the specific feature extraction, but instead just feed in the real data and then annotate the data for pass and fail. So that the user can be continuously improving the data over time when the system is running. It provides higher accuracy and easy to configure and less time consuming for long-term development as well. And I want to share with you OVST EdTech that allow the professional and academic to learn industrial application in just 3 steps. Just log into the EdTech OVST website and enroll the user, and then you can learn and create your own application. So I will share a little bit more detail of with these 4 steps. You can run the virtual hardware and software simulator and use the real-world industrial experience to create your own application. With OVST EdTech platform, you can build self-direct and online study, and you can simulate both hardware and software by using the actual system information from the industry. And you can design a system project using the virtual hardware, software, and write your own script and programming. And more importantly, once you develop this system, you can deploy such system in the actual environment in the manufacturing, meaning that your work can be implemented in the actual production process. So with OVST EdTech, we focus on vision system, robotics, and industrial Internet of Things, allow the user to learn innovative technology that clearly will be implemented in many of the manufacturing production line. So with OVST EdTech, we have multiple courses that actually we charge for the industrial customer, but for the student, and we have collaborative with the community university, we actually provide it for free access or for students that allow them to be able to learn and make use of industrial application without the need of hardware. And for example, we can see collaborative robot integrated with the 3D vision sensor. And we write our own firmware in the robot controller. As you can see that the graphic and design is our own software and firmware that the robot programmer can access it in the robot pendant. And we work on the platform of Universal Robot, one of the biggest collaborative robots in the industry. And you can see our application in Universal Robot website as well. So as you can see that we can see robot and industrial application running in manufacturer, or it can run in the workshop, and it can run in the simulator platform just within the laptop and computer with using all of these industrial hardware. I'd like to share with you some examples of successful students who have an internship and learn our technology. This is the more recent year of students. So they have a great academic from Quality University, and on top of that, they learn industrial experience, and all of these students have been outright get the great job even before they graduate at the university. So I congratulate them for this. So we can see that with the experience, with the great academic and industrial application experience, it really allows students to be successful on career searching after the graduate. And we also work with Quality University for number of years, and we provided our platform for students to learn with us, and we provide internship for the student to learn multiple fields of AI, machine learning, robotics, and develop with the real hardware and software, including the simulator platform. And we will continue to doing so. So we can see that with all of these, that allow the student to have the career path with their great academic research, as well as the industrial experience for them to be ready to get to the industry. And talking about going to the industry, I like to share my experience that would be useful for a student to learn, like after they graduate, myself included. When I graduate, I ask myself where I'm going, and I hope this my experience will be beneficial to the student that going to graduate in the coming years. So some students and some people, myself included, we want to work in the startup or a large company that work with high technology that allow us to learn a very innovative technology to gain experience, either small startup or the large company. So we focus on technology and experience if we wanted to get into startup environment. And some people, like to go to startup ecosystem. And I like to share with you my experience that in the UK, they have multiple institutions that provide grant funding, provide opportunity to the student who have ambition to entering the startup ecosystem, so that I encourage you all to look for such opportunity if you really need to get into the startup environment. And talking about startup, and we are at the academic institution, so we may have to talk about the spin out. We can see that for the startup or spin out from university, which area that dominant in the field. We can see that in the past, we can see pharmaceutical, medical research is always the forefront of the startup or spin out area. However, the emerging sector, as we can see, that AI, artificial intelligence, and machine learning, big data, they are the forefront of this area. So that, and I know that Coventry University have a great department for industrial automation and AI, and I can see you have a great future career in front of you. And also you can see like it's more than 140 universities in the UK, and you can see that they have a lot of universities that successfully created the successful spin out. Coventry University also included as well. So that we can see there are opportunity for students, even they are still studying for MSc, for BSc, or for PhD, they can also seek for the startup opportunity even they are still at the university. If you can see successful startup running across university, as we can see here, there are a lot of opportunity there. And just talking about startup, this is a great information to share. You know, a lot of startup fail, as we know, but the data show that with the startup that emerged from university, the failure rate or the successful rate is much higher than you create startup out of academic. So this share with you with that it's a great opportunity to create a startup out of the academic environment. And last but not least, I hope this presentation beneficial you all. And I want to share with you and encourage you to pay it forward. So I'm so grateful that I have so many opportunities in the past to have many institutions and people supporting me to get to my career and creating a startup. And I like to share with you my experience, and I want to encourage you to share your experience that would be helping other people, like what we are doing now, that we are coming together to help to give people a better future, a better career. And I hope that all of us continue doing so.